Hello everyone, welcome to Gamma. This is Ripple, and I'm here today to give you an introduction to my upcoming event 90 minutes extended series. This event 90 minutes extended series is an extension of a previous event that I did in April 2020. Um, this would be a conclusive event for the first season of 90 minutes. And today I would be talking about um, one of the projects. This project is a terrestrial ecosystem, an artificial terrestrial ecosystem, which was proposed in the lowland rainforest regions near Ramboda, if that's the correct pronunciation. It's in Sri Lanka, and me and my team, we were working on this project almost like a year ago from now, and these were some of the initial um, sketches or initial images that we had developed. A lot of design changes have happened in this time, and it doesn't. The design is quite different from the way it looks right now in the images. So I decided that maybe I could just give you a small introduction um, of this project and the way we created this shell. So today's tutorial would be on developing this shell that more or less covers quite a good area of this ecosystem. So this tutorial would be in two parts. The first part would be done by me, where I would be giving you um, information about, or I would be introducing you to this geometry and the steps for creating this shells. And in the second part, Anuj would be explaining you some methods that we could adopt to present our work. And I think this tutorial in general, it defines the workflow of the extended series. So it's gonna start on 25th of May, and it's gonna be there till 29th. So it's a 5 days, a 5 day session. 3 days we would be engaged in creating our content on Grasshopper, on Rhino, and then in the following 2 days, Anuj would be explaining some quick illustration methods and rendering techniques, so that uh, people could improve their presentation skills, and they could have more clarity um, in their presentation while composing their designs. It could be useful for people who are working on their portfolios or developing their website, even personal blogs, or even social media content. So just to make your work more interesting, we thought like it would be better to give you an introduction um, of the design process till the end, where while we present. So let's go ahead and let's start to create this roof or the shell that we created for this project. So the tutorial is gonna be on this shell. To talk a bit more about the design process, because I don't have a lot of time and I wouldn't really like to reveal every aspect of this project. I'm just gonna go through some quick introduction about this project. So um, the site which was provided to us was more or less squarish region, and you can see that we just tried to uh, put a volume on that side which could be used for developing the program. The program included some research labs for various purposes, some nurseries, and some controlled areas with different temperatures. So we were thinking of deconstructing the mass and create a kind of staggered or more create a in under which could be buried underground and which could have like a central area where we could develop an artificial ecosystem with a kind of flora and fauna which research labs could test on. And from there we were working on different kind of shells that could cover this whole ecosystem. So you can see like some of the options that we created during this process, and the one which we thought could be the most useful one was this. um, you can see an exploded version of this, like which shows the division of division of the volumes, and the shell as well. So these are some of the images, and I would like to now just formally give you a better understanding about how we could create this kind of roofing or this kind of shell. So I'm gonna hide this whole, or in fact, I could just leave one for my reference and I can just hide everything else. So when I go to my perspective view, okay, so I do have some things on the screen existing from my uh, working Grasshopper file, but I think I'm just gonna start over fresh. So let me just hide everything, even in Grasshopper, and I could just start. Okay, to start with this geometry, I would first hide this because it seems that it's better if I keep nothing on the screen and start fresh. So to start with, I'm just gonna put a curve which is a circle. I would attach a radius between 0 to say 50. So that's gonna be my first step. Um, so what I'm gonna do is I would like to create some series of curves. Um, Give it a different height, give it a different scale, and then loft them all together. And at the end, or as we move ahead, I'm gonna show you what inspired us a bit. What inspired us um, to think differently about this project. So I'm just gonna reveal that once we are through with some process. Okay, so I'm gonna move this very quickly in my Z direction, and I know that I would require, I'm gonna take um, three values, so I'm just gonna have a merge component. I'm gonna merge three values, so let's say that my first value is around 20, and my second value could be around 15, and my third value could be 0 or something in negative. Okay, so these are the three values that I have. Okay, and now what I could do is I would like to scale them up. So I have my area. I could use my area component to get the center, and I'm gonna scale all of them. Again, I would use number sliders. So I'm gonna merge some things between 0 to 2. Let's say my top curve is of the same scale, my second gets reduced, and the third one could be the least. So this could be zero point 0.5, or sorry, zero point 0.1. This could be around zero point 0.5 or something, and this could be a bit bigger, let's say 1.2. And I'm gonna attach this to my so you can see that um, I have these curves. Now if I just loft all of them together, I could see that I could form uh, some things here. It's good to have some quick visualization of the geometry that you create. Um, so eventually that helps you in building some confidence that okay, uh, okay, I can just change my scale as per uh, say the way it looks. Okay, so let's let this be something. Now, what I would like to do is I would like to just um, say I would just like to um, insert or have my initial curve, which is this, as a part of my lofted geometry as well. So the way I'm gonna do this um, is by just doing an insert, or in fact we could insert an item. So this is an insert item. I would like to insert this curve at in sorry, it takes in the first is the list to modify. So this is the list to modify. This is the list that needs to be inserted, and I'm just gonna say just to insert this at 0. And if I just attach this, you can see that I have a geometry which looks some things like this. Okay, so now this is good. uh, let's keep this as our first quick visualization. I can maybe change all of these scale to get different kinds of shells. So I could take some things from here as well. Uh, okay, let's move ahead, and I'm just gonna hide this. These are my initial curves. What I would like to do now is um, I would like to change uh, this curve, and as I said that I'm gonna reveal um, some things about say a deep inspiration for this project. We were kind of interested in learning more about um, wavelengths and frequencies in nature, so we thought we should keep our shell because we believe, I mean, as per our research, we were convinced that most of the things living are made out of wavelengths at different frequencies. So I think we were just convinced and we were just quite inspired by that um, thought. So we thought, okay, we should add some of the elements. So we were working with sine waves, and I'm gonna use sine waves to maybe change or show you some things cool about the shell structure that we created from there. So I'm gonna put a graph mapper and I'm gonna uh, have a sine wave here. What we would like to do here is we would like to change the top of top curve to follow a sine function. So the way we would like to do this is uh, we could just list the last element of or the first element of uh, our curves, and we would just like to divide this curve. So I'm gonna divide this curve and I'm gonna put in some good number of points, let's say around 100. Okay, let's say around 100. Okay, so these are, and now what I'm gonna do is I would like to take an average. So I'm gonna take an average of these points. I would like to learn the vector between all the points and the average, uh, that average point that I found. So once I get that vector, I would like to move all of these points um, towards this vector. So I'm gonna put in an amplitude and my vector goes in. So this is like the movement that it shows, and this movement should be governed by my graph mapper, the sine wave that I uh, introduce here. So I'm gonna put in a range, and my range would have um, the length of the steps equal to the list length, number of points, minus 1. So in the expression, I'm gonna put x minus 1. Okay, and my domain stays between 0 to 1, so I could just keep it uh, even if I don't attach anything, the domain would be between 0 to 1. But let's say I might think of changing some things, so I'm gonna put in my domain and it should be between 0 to 1. So this is 0, this is 1. Also, I would like to have, I'm gonna take this a bit ahead. Also, I would like to add an expression which multiplies the value that I have from uh, this sine function by a multiplier. So let's say in this case the multiplier is around 0 to 10 and I give a multiplication value of 5, and I'm gonna attach this to my amplitude, and you can see, well, so this is my point, this is my vector. Let me check what are the results that I get here, and what are the results that I get here. Oh yeah, I need to set my domain between 0 to 1. So now you can see that as I change my sine function, my curves, I can see the change happening in my curves as well. So you can, I can just maybe use this, okay, and say something. I'm gonna be, so this is um, this is something, you can say that this is some value that I have for my existing curve. Now what I would like to also add here would be like, not just it has to, the points has to move uh, in a flat 2D plane, but it also have to be, it has to be seen as it goes around this whole, as it goes around this, or as it takes the form of this circle. So the way I could do this is by, so also I would like to just maybe lift this a bit up. Okay, so the way I'm gonna do this is by having uh, the number of I would like to divide this points with uh, this initial curve. So let's take this curve. Okay, I'm gonna use this, and I'm gonna use the same number of divisions that I have used here. And what I could do is I could just form a line between this point and this point. So you can see like I have these points. Now what I'm gonna do is I need to have some points which more or less follows the same uh, sine function. So the way I could do is I could have an evaluate curve, and I would give in all these curves, reparameterize it, and I would put um, the values from my sine function directly, because it's between 0 and 1. Okay, so now, and I could put in an interpolate to see how my curve looks. Okay, and eventually I would like to replace, um, I would like to replace my first item of this list with this curve. So I could put this, and in I could just put my integer as 0, and now when I loft this, also I need to have my, yeah, so I have set my periodic to true. It closes this curve. My periodic um, curve should be turned true. Okay, the next step that I'm gonna take here is to create some panels. So you can see that from these images, so I have these, kind of panels. Okay, so how could I create these kind of panels in my geometry? That's gonna be my next step. So I'm gonna be using Lunchbox for um, I'm gonna be using Lunchbox for this. uh, creating panels over this geometry. However, um, I can't really use this plugin directly. So if you go to um, so if you have Lunchbox, you would see some things like this. All these components would be available to you from the Lunchbox plugin. And then you can go to your panels and you can select your diamond panels. So I can't really plug this directly because this is not a surface, it's a B-rep. So because it's a B-rep, my Lunchbox plugin might not take this, so I'm not gonna be directly plugging this. Instead, what I would do is I would like to create this loft by using another method. So I'm just gonna group this and I'm gonna hide this for now. What I could do is I have all these, let's take a copy of this. Let's say I have all these curves. I would like to divide these curves. Okay, once I divide these curves with some division values, say around 80. Okay, I would be doing a flip matrix. So when I do that, my list, the orientation of my list is changed, and I could interpolate. I could interpolate these points again. So now I can see that I have this nice interpolation between the curve, the points of the curves that I have. Also, what I would do very quickly is I would like to create these groups. So let me just do that and clean this script up a bit. Okay, I think I always say this, that it's a good habit to um, have your components grouped well together. So this I need to remove. Okay, so this is good. Okay, the next step that I'm gonna take here is I'm gonna do a shift list. I would shift this list and I'm gonna merge my my previous list and the shifted list together. I have to I have to graph this. I have to graph this. I need to flatten both my lists so that uh, my data is sorted, and I could just loft this now. Okay, now I can use this loft to create my diamond panels. So now you can see that my panels are getting created because now the way I formed a surface. um, and I would like to change my use and v's. Let's take use as around 2 and between 0 and v, it might be around 50. So let's take this value to start with and see. Okay, so that's fine. Okay, so now you can see that I have my diamond panels are created, and uh, I have these values to control my divisions. Okay, I'm gonna group this again. Okay, this could be grouped as well, but let's maybe. Okay, So this is not just random grouping, but when you see this file in your exercise, in the exercise, when you find this file in the exercise folder, you would see, like, I would have written the purpose of this group. So what are we getting as an output? So, and that's some things I think you should be having a practice, or maybe you should have a habit, in fact, of grouping this and then writing about, like, the reason why you have these elements in the group. So in this case, maybe getting values um, from this sign function. So that's the uh, aim of that's the objective that we have to or checkpoint that we have to mark with this group. Here I'm my dividing the first element of the list. Okay, so that's my top curve, uh, which I eventually divided and made the points following a sine function in my x and my z direction. Okay, so I'm gonna go ahead now, and what I'm gonna do is I would take all the diamond panels which are there. I'm gonna take out the area of all these diamond panels, and maybe I could start a bit low, maybe at 20, so that you guys would understand um, you guys could understand the changes that happens on the geometry. So the next step that I'm gonna do here is um, I would like to create some uh, porosity in my shell, um, and that porosity should be governed by say the distance from the center till the center to the points which are, or the centers which are available to us. So I could do an average of all these points so that I could get the center. I could just flatten this and I could get the center of this. I could find the distance between them. Okay, once, so I have these centers, I could, in fact, this is a bit early. What I would do before this is I would like to evaluate some panels. So if my panel, the area of the panel is less than some value that I ask for, or some value that I provide, then it could be like it doesn't follow the further functions, or it doesn't get transformed with my further steps. So what I could do is I could put in an expression which says x lesser than y, and I provide uh, so this is the x, which is the area, and I provide the y. So I can check from I can check from by bound component that what is the minimum and the maximum that I have in these. Uh, so I can just flatten this list and I can see that my minimum area is around 0.18 and my maximum is around 6.4. So what I could do is I could just put a number slider between 0 to 10, and I could just say that give me all the areas above 3. Okay, and you would get a true and false value uh, as an output from this particular function. So you could use this data to dispatch your lists of all the diamond panels. So you have all these values and you can just dispatch the ones which are true. So in the geometry, I can see that I have all these uh, amongst all the diamond panels that I have all of these which are true, are which has area over 3. Okay, so over 3. So that's my first condition. I have these values, and you can see that these are all the diamond panels which has area lesser than 3. So I would require both of them as I go ahead. So I'm gonna keep them both. So next thing that I'm gonna do here is I would attach um, so now what I'm interested in is um, I have these average values, so I can use this average and I can check the distance of all of these diamond panels from all of my diamond panels from these values. So I need to have area for this as well so that I could get the center. Okay, so once I have the center, I would know what's distance, and this value I could use for um, I could remap these values and I could scale all these panels up. So I could use these panels and their center, and I can remap the values. So for my remapping, I would require the values which I have. My values which needs to be remapped is the distance value. We using the bounds, we could learn the minimum and the maximum of these, um, and I could construct my domain. So my in the construct domain, let's put the value from zero point 0.5 to 1, sorry, 0 to 1, and let my values be between, say, the minimum has the distance would get zero point 0.5 scaling factor, and the maximum length would get zero point 0.9 as my scaling factor. Okay, so that's 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 the target domain, and in let's put that in our so I'm just gonna select a bit more so that you can see the effect on the geometry. So I have these. I could take out the curves of these, and I would require the curves of the panels that I have used. So this one, and what I'm gonna do is I'm just gonna merge uh, both these values, and I could just loft it. So I would just like to flatten them both. Okay, and here I could just graph them, and then I could loft it. So now I can see that I have these uh, geometries which follows, I mean, which eventually is scaled by the distance value from the center. Okay, so I'm gonna do the same for um, my triangle as well. So what I could do is I could just keep this separate, and I would like to make a cluster of all of these components. Okay, and I could just put an output cluster, or let's say output. Yeah, so that's gonna be my cluster output. Okay, which are these lofted values. um, And also I would like to have these geometries which I have not used, so I can just remove these from the groups. Okay, so I can just use these geometry as an output as well. So what I could do is I could just merge both these values, and I can say give me an output of these. Okay, so all of these and these are now a part of my cluster. Okay, so that's an easy way of making your um, groups into component. Okay, your custom component, I would say. So it takes in the surface. Okay, I could just go in my cluster, and if I would like, I could change uh, some part of these values as well. So I know my Y. Um, I could attach the same to my list, so I can just delete this. I So the aim is to like reduce as many input as you can. So these are my input. Um, this is my say evaluation value. So, and this is the start domain, and this is my end domain. Okay, so once that is done, um, you have you have your geometry which is output through this cluster. You can have a similar cluster copied, and you can put your triangles, all the triangular panels as your geometry. Now what you could do is you could just uh, give some value for evaluation, so that uh, let's say you have some triangles uh, whose area could be around, so the minimum area that needs to go in the evaluation could be around say 0.5. So I would just wait for my grasshopper to resume. Okay, so let's say it has 0.45, so let's say 0.7 or something is like the minimum value, and I could change my start and end domain so that I could control the thickness of my triangular panels separately. Okay, could just wait for my grasshopper to resume. Okay, so now once I have these, I mean most of the things are done already. I have uh, I can increase my I can increase the number of panels if I would like, but maybe I could just use this to show you a demonstration very quickly. So let's take this to around say 35 or something. Okay. and this could be, say, 25. So you can change your change the parameters your uh, as per your preference. What I could also do very quickly is I could just merge both the data, this one and this one, and I could use a custom preview. Okay, so I could use this custom preview in case I don't like, I wouldn't like to render everything. I could just use this and I can put a color swatch um, with whatever. Okay, let's use this maybe. Okay, so this is what you could do very quickly if you. Okay, so the scripts would be available in the exercise file, so you can have a look at it properly. And from here, I think Anuj would just cover up in the second part that how you could create or take this geometry and represent it. Um, and as I was saying that we have this process. So just to give you a glimpse of that process, we would be interested in learning how we could document that process. Uh, so all these kind of quick renders from Rhino itself could um, go as kind of illustrative work in your documentation. And this is more or less the illustrative process that we have. So um, we could show this process quite efficiently. Okay, so we can start from the side, available mass, the way we divided and staggered kind of shell options that we have, and the final one that we picked. So all these things could be very well documented. So that's about the first part of this free extended session. I hope that you guys find it interesting. Feel free to provide any uh, comments or let us know more what we could uh, make as content. Give us some topics so that could interest us as well as interest you. Uh, any kind of challenge would be accepted. Um, we would love to get into this kind of skill development challenges, so feel free to provide us with any. And Anuj would take it from here in the part two. And I hope to see you all, I mean, the participants, um, in my next event starting from 25th. Thank you very much.